just yesterday. So what we're learning is sum of arithmetic series. So yesterday we learned how to locate the term of an arithmetic series. So this is all in your formula sheet. I don't know if that one is though. So it comes in two formulas. So the sum of an arithmetic series there, or it's the same formula, but this one is if you know the first term and the last term. L stands for last term. Okay? If you don't know the last term, it's very similar to that, but just a bit more added on, but you know what they will represent from yesterday's lesson. So I'm going to show you girls quite a few examples because they're all quite important. Let's have a look at the first example. So if you have a look at example 15, it's a very basic question to start off with. So you've got the series starting with this. They want you to find the sum of the first 20 terms. So S20 is what they're asking for. So in order to know that, let's plug it in here. So from here, we know what that is. There are 20 terms. So n is 20 over 2. 2a, girls. What's a stand from yesterday? The first term. So that's going to be 2 times 3. Or I'll just write 2 times 3. Plus n minus 1 becomes... Yeah, I'll just write the simplified version. And the difference, it's going up by 2. Yeah? So it's just a matter of plugging into the formula. And if you do this, it's pretty cool. I think this is a good formula to know. Let's have a look at a question where we have to go backwards. In this case, it says, how many terms from here do we need to add so that it equals to 531? So how many terms do we need? So we have to work backwards. It's the same thing. So now, before you do any question, I think it's sometimes good to take a step back and go, do we know the first and the last term? No. So you're always going to resort to that formula, but sometimes we're so used to using that formula, we forget to use that formula, which makes your life so much easier sometimes. We don't know the last term, so we've got to use that. So let's do this, girls. Using that, once again, 2 times 4 is 8, plus n minus 1. What's my d? Hello? Okay. Yeah, so this I should have written really as 531. Okay? So, girls, I'm not going to go through that algebra work. Do I need to show it? Yeah. Times the 2 across, that's 1062 is equal to, then that just leaves n bracket 8 plus 3n minus 3. All right. And then this is, what's that? 5. Oh, it's a quadratic equation. Can you see it? That's annoying. 1062, 5n plus 3n squared. Okay, when I did this last night, I just resorted to the quadratic formula straight away. I didn't want to think about factorizing this. Yeah? Girls? Use the quadratic formula and you'll get your answer. Listening. When you use a quadratic formula, you're going to get these two answers. Obviously, you take that one. Okay? So it requires 18 terms to add up to 531. Okay, so use quadratic formula to solve that. All right, example 17. Now, find the sum of the first 20 terms. So in another way, let's write the symbols down as we go. So find this, given that the 10th term, so T10 is 39, and the sum of the first 10 terms is 165. Does that make sense? I've just read the question, I've simplified in terms of the symbols. That's what they're asking, given that. Yeah, so look, I won't do the whole working out, but you know what to do. So now from here though, I'm using that formula. Do we know A? No, we don't. So T10 is 39, so 39 is equal to A plus n minus 1, in this case is 10 minus 1, which is 9. We don't know the difference either, so leave it at that. And then we want to come up with another simultaneous equation from this. S10, this one, we can't use this one because once again, we don't know the last term. But I feel like you rarely use that formula, but sometimes when we can, we forget about it. So that is 165 is equal to, do we know, come on girls, stay with me, what's my n over 2 in this case? 10 over 2, which is 5. And then 2a plus what? 9d, because 10 minus 1. Okay? So 165 is equal to 10a plus 45d. So, yep, there are your two equations that you need to solve. I'm not going to go through that working out. If you go through with that, you're going to get a equals to minus 6 and d equals to 5. Okay? Okay. So that's your answer. Oh, wait. Oh, sorry. I forgot to do the question. And then just sub it back in here. Yeah, okay. Yeah, so look, just see you're working out. But if you plug it in, I'll just write down the working out, all right? 20 over 2, 2 times minus 6, plus 19 times 5. If you do this, you'll get 830. Okay? All right, now, example 18. A little bit of a tricky question, but it's not hard. Yes? Are we looking at example 18 now? Find the first 3 terms of the arithmetic series defined by this. Okay, so they want you to find T1, T2, T3 given just an expression. How the hell do you do that? Well, the textbook's given you 2 methods. I don't like how they've done in the first method. All right, so girls, in order to get this one first, girls, wouldn't S1 basically be the first term? Does that make sense? Yeah? So, let's figure out what S1 is. So if I plug in 1 in here, I'm going to get 2 times 1 squared plus 1. That's 3. Yeah? So my first term is actually 3. So they want the first 3 terms. So let's try and figure out the second one. You want to do the same thing. Let's figure out what S2 is by substituting 2 in there. That's 2 times 2 squared plus 2. That's 2 times 4 plus 2. That's 10, right? Now, how do we figure out what the second term is given the first 2 terms added is 10? Yeah, that's right. So that's the easiest way to go about it. Okay? And then, like even from here, you can obviously see what it's going up by. So what's it going up by? 4. So that means the next number has to be 11. That would be the easiest way to go about it. Okay? Yes, just wanted to show you that. All right, now let's do some harder questions from the actual exercise itself. I had a look at all the questions from this exercise. I know it seems long, but they're all so different types of good questions, so I don't want you to skip any except those, though. They're just ridiculously hard and unnecessarily hard, so I feel like you can skip that. Let's have a look at some of the questions that I thought you might get stuck on, which I did as well. Let's have a look at question 16, girls. Some of this is just a guide, so it won't take long. Question 16. I'm going to read the question now. Girls, get it in front of you. The sum of the magnitudes of the angles of an irregular pentagon. Okay? Keep that in mind. It's an irregular pentagon is 540. So let me just draw you a quick diagram of what that means. So I can have something like this. Irregular. So something like that. So this is an irregular pentagon, girls. Girls, come on, listen. The magnitudes of the angles form the terms of an arithmetic series. If the largest angle has a magnitude of 136, find the magnitude of each of the other 4 angles. So what that means is, from here, just look at my diagram. Let's just say that's the largest angle, 136. Okay? What they're asking is find, what's the question? Find the, yeah, so you got to find out what that angle is, that angle is, that angle is, that angle is, given that, and how many angles are there? So given that S5 is, what does it say? 540. That's the question. Okay? And it says if the largest angle has a magnitude of 136. So if that's the largest angle though, what term is that? That's the last term. So let's just say it starts from here. 1, 2, 3, 4, 5. So given S5 and T5 is 136, figure out what those angles are. Okay, I'll leave that for you guys to do. It's the same idea as basically what I did somewhere out here, like that. Yeah. Okay, so can I leave that for you girls? Okay, so S5, plug that formula in there. T5, plug it in there. Simultaneously, great. Actually, no. Oh, yeah, you can try it out with that. Yep. Yeah, or you can try that out. Yeah, I actually haven't fully figured it out. Either will work. Okay? All right. Next tricky question. Let's have a look at 18, please. I have to... Yeah. So I'll leave that. Simultaneous square. I'll leave that for you guys. 18. Girls, I didn't know what the word meant. I actually had to Google it. The rungs of a ladder. Do you know what a rung is? Yeah, sorry. I didn't know. I had to Google it. So this is what the picture is. Yeah, so you got a ladder. And the rungs of a ladder decrease in length. So that made sense when I Googled it. Like these are, yeah. So obviously the rungs decrease over time, like you got that, right? So this is the rung. All right. Read the question, stay with me. The rungs of a ladder, come on, be quiet. The rungs of a ladder decrease in length uniformly from 40 centimeters at the bottom. So you got 40 centimeters down here, and then all the way up to the top is 30 centimeters. Now, these aren't how many rungs there are. This is just an illustration, okay? Now, it says how many rungs are there. So yeah, what's my n basically? How many rungs are there if the total length of all the rungs is 5.25 meters? So if Sn, now here's a tricky part though. Don't do this. Why? This is in centimeters. The question's given it to you in. So you want to write it like that. So that's another trap for. It's like when I looked at it first without looking at the unit, I was like, how does 40 all the way to 30 add up to 5.25 centimeters? This doesn't make sense, especially because of the fact when I didn't even know what a rung meant. It's like, is this something else? Yeah, so just keep that in mind. That's all I wanted to show. You know what to do from there, or hopefully. So this is your A. That's your last term. Yeah. Okay? All right. Now, 28 is a tricky question. Take a photo of logs of wood are stacked into a pile. Yeah, this is a typical trial type of exam questions as well that I come across. They're stacked in a pile so that there are 15 logs on top row. So, and then 16 on the next row. So you've got 15 there. Girls, you with me? And then you go 16 on the next row, 17 on the next, and so on. If there are 246 logs together, how many rows are there? So all I wanted to mention from here is labeling the numbers. What is it? That's difference is just 1, yeah? Yeah. And then Sn is?
246.
Yeah, that's all I wanted to show. I just thought, for the first glance, it might seem tricky. Work with that, and then you'll get your answer. You're looking for how many rows are there? You're looking for n. How? Yeah, Sn formula. Sn formula. No. Now, for B, you need to know what Tn is. How many logs are there on the bottom row? Why are you confused? Okay. All right. So we have this. It's natural to use Sn formula because we have Sn, right? So from there, 246 equals 2. N over 2, because we don't know what n is, that's the question. 2 times A is 30 plus n minus 1 is just literally just n minus 1 because D is just 1. It's just, yep. Times that across. It's literally like what I've done here. It's going to be quadratic again. 400, I can't read my writing, 492. Yeah, so look, I'll just leave it here, okay? Yeah. There you go. Solve for n using quadratic formula and you'll get it. Yeah. All right, girls, that's it from me. Do all of the exercise questions except for 21, 33, 36. Thanks, girls. Hit stop now.